Okay, so what we're going to do here is using a clinometer, right? Now, what a clinometer is, I'll just quickly demo what how a clinometer works. You get a protractor. You put it upside down, okay? And what you do is you actually look through this clinometer. So I'll just do a little diagram here like this. That's it there, zoomed out. And what we want to do is we want to look at something that's a taller building than ourselves, yeah? So we're looking up to see what angle it is to look up to the top of a building or top of a tree. So what a clinometer has is it has a weight that goes down the middle, like this, yeah? It also has, when you're looking straight ahead, the clinometer hangs straight down. If I want to look up at this angle here, what I do is the clinometer tilts. So do you see the way it starts off at 90? Does everyone see that? It starts off at 90, then we tilt the clinometer until it hits the angle we're looking for. I actually just realized I need to center this a bit better. There we are. Go again. And there. Stop there. Right? Now, what angle do I stop at now? It's around 130, isn't it? What's the difference between 90 and 130? 40. So this means that this angle here is 40 degrees. Okay? We do the same thing with this clinometer here. It used to be at 90, but now it's at a new value. We take the old value away from the new value. So in this case we read 10, 20, 30, 40, 50, 60. In between 60 and 70? 65. Now here's the problem. You're on 65, but you would have began at 90. You always begin at 90 when using a clinometer. So what's the difference in the angle? 90 minus 65 gets me 25. Now, if you put in 65 for this here, yeah, how would you know you're sort of wrong? You could always get your protractor in your exam and you could just measure it. And what's the measure there? 0, 10, 20, 25. If you had 65, you'd know you're well off. Okay? So that's how you use it. So what we get? 25 degrees. Okay, now we're on this part. That's 25 degrees. What's the next part it wants us to do? It wants us to calculate the height h shown in the diagram. So what's the height h shown in the diagram? The height of the tree from the it's like the hedge section of the tree, isn't it? So can anybody tell me if this is the angle we're going to use, what side is h? H is this side here. It's the opposite. Yeah? Which side do we know the value of? The hypotenuse is the green line here. We don't know anything about the hypotenuse. We know the adjacent side is 10. Which two sides am I going to use? I want the opposite, but I got to use the adjacent, because adjacent is the one I know the value of. So what function should I use, Aaron? Remember you told me earlier? Why tan? Perfect. Tan of what angle? Tan 25 equals, what's opposite over adjacent? Over 10. Now you want to get the h on its own, so how'd you do that? So bring the 10 over to your side. Well done. And what is 10 tan 25? 4.66. Correct the 2 decimal places. 4.66 meters. Okay, that's brilliant. Now, we know the length of the red line, don't we? But is that the total height of the tree? What's the total height of the tree? At the what height? At the guy's height. Add 1.75 onto the existing answer. So 4.66 plus 1.75, and what you get? Probably need to use a calculator for it. 6.41. Now, another student uses the same method as Sean and finds the height of the tree to be 23.1 meters. Sean did not get this answer. Give one possible reason why the answers might be different. Yeah, maybe they measured the angle wrong. The angle's very easy to get wrong, isn't it? Or maybe they used 65 degrees. Do you remember most of you guys were going to use 65 degrees? What would happen if you were using 65 degrees imagine you use 65 degrees what was he going to say? Use 65 degrees instead of the one you're meant to use. How high would that tree be? 65 degrees would be something up here, wouldn't it? And then the tree would be so much bigger. No, you can just say, look, you can just say it's a much taller tree. Probably used the wrong angle. Yeah. So what you could do instead, now Joaquin, smart man, he's going back to Spain, is that instead of using 25, Joaquin suggests we used 65. So h equals 10 tan 65, and he rightly told us that is 24 meters around. 23.1, is it? So you can see that this person used the wrong angle. He thought it was 65 degrees instead of 25. Now, next question. The diagram below shows the angle A in the right angle triangle. Indicate which side is adjacent, opposite, and in relation to the angle A. So this one. Okay, and the one on top, hypotenuse. Okay. Which one's opposite over hypotenuse? Which one? Uh, Opposite over hypotenuse, Hushin. O and H. Cos is? You just had to spell that in. It's a bit tight for me. And the last one? Opposite over adjacent. Fair enough. In the right angle triangle below, you listening? B equals 35 degrees and the opposite side is 12. Find the length of the hypotenuse correct to the nearest centimetre. So how do you do it now? What side do we want to find? Hypotenuse, yeah? Call it X, yeah? You want the hypotenuse and you know the opposite. You know that B is? Okay, which function? Cos? Nope. Opposite hypotenuse. Sin. Sin 35 is what? Uh, 12 over. Okay, this is a tough one, alright? First thing, get the 12 on its own. Once we get the 12 on its own? No, look, Aaron. This time it's on it's 12 is on the top, not the bottom. Bring the x over first, okay? And then where does the sine 35 go then? Underneath or beside or above? because it's multiply on the left, which means it's divide on the right. So what's 12 over sine 35? Yeah, 20.92. To the nearest centimeter, it's 21 centimeters.